Hi everyone and welcome back to the channel. Now today is going to be epic because I'm going to show you how you can make carbon fibre parts at home for your bike with no specialist tools or equipment. The only specialist tool I'm using in this video is a 3D printer, but even those are pretty hobby machines these days. You can get them quite cheap. Anyway, a big thank you to Easy Composites. Who are Easy Composites? Well, they're the biggest kind of one-stop shop in the UK and Europe for supplying carbon fibre reinforcements, all the tools you need, all the materials you need, all the resins. They supply individuals like myself, DIY makers, hobbyists, small to medium businesses and large industry as well. Also go and check out their YouTube channel. All the techniques shown in this video you can also learn on that YouTube channel as well. You may have seen my original mudguard video where I actually 3D printed a custom mudguard for my TCR, and in that video I mentioned that I've had clip-on mudguards before for road race bikes and they've not been that good. They're floppy, they don't fit that well, they're hard to adjust, and that's kind of understandable really because they're not really optimized for a single bike. They're designed to fit loads of different bikes. But I thought, hey, I am an engineer, I've got a 3D printer, why don't I just 3D print a mudguard for my bike that's going to fit in the way I want it. So I did that. 3D printed this pretty big phallus looking thing that was quite thick, quite chunky, and it was actually quite heavy because the amount of plastic you need to get the strength, because FDM 3D printing is not very strong. But as a proof of concept, it worked really well. And after putting it on the bike, I thought, well, actually, this is like a perfect mold to make a carbon fibre skin from. So if I lay carbon fibre into the inside of this mold, I could make a really light, really optimised single skin carbon fibre mudguard for the rear of the bike. So I got in touch with Easy Composites and said, do you kind of think this is doable with this 3D printed mould? They said, yes, absolutely. We'd love to see you do it on YouTube. Can we send you some materials? So I said, let's do it. Before laying quite a lot of expensive carbon fibres into this mould, this 3D printed mould, why don't I design something a little bit smaller, something I can kind of get my eye in, practice my technique, because I used to do a bit of carbon fibre layup with pre-preg carbon fibre, not since my uni days, over 10, 11 years ago when I was working on the Formula Student race car, and that was using pre-preg, and that's kind of a lot easier because the resin is already in that fabric. Now in this video we're going to be using wet layup, so you've got dry carbon cloth, which is very hard to work with, very easy to fray. Even if you breathe on it, it'll start to fray, and then a wet layup. If you put the work in, the results are really, really rewarding, as you'll see in this video. So first of all, I thought, let's get my eye in, let's design a little ass saver. It's going to use less carbon, it's going to be easier to make a mold. So here you can see in CAD, I've designed the ass saver, the final form that I wanted it to look like. The clip-on system to the back of the seat is going to be pretty novel, and we'll come to that in a bit. And the reason I wanted to make an ass saver is because all the ones I've had in the past are pretty crap, pretty flimsy, they flop around, they twist, they don't really stay central on the saddle, and they've just generally been pretty crap, so I don't use them. Here we can see the outer skin shape of the final piece. It's going to be about 0.8 to a mil thick in carbon fibre, and then from that we can make the mould. Now the mould is a female mould. I'll be 3D printing it in 2 halves. Now time invested here in the prep work to make the surface finish really, really good. It's going to save you a lot of sanding, a lot of post finishing to the carbon part. After that, glue them together. Here's some little locating features you see here. I've used these kind of tolerance holes and pins, which I know the tolerance of, so I don't need to hold it, I don't need to clamp it when I'm gluing it together. Just a quick abrade of the gluing surfaces, and then I've glued it together with basically cyanoacrylate glue, which is super glue, and then put the parts together. Now after that, a lot of sanding is required to get rid of the layer lines in the 3D printed surface. Now you could leave those layer lines in, but they're going to show up on the final mould. So I decided to sand it back as flat as I could with grits of sandpaper ranging from 240 and went all the way up to 800. So here you can see me sealing the mould with a kind of top coat resin, and this is the sort of resin that you would put on the top coat of a finished part, but here I'm using it to seal the mould and make it really, really nice and smooth. I did 2 coats of that, flattening it back each time to get a really, really nice smooth surface, and then finally I polished it up with a bit of basically carved polish. Draft angles, we've got at least 6 degrees of draft angle everywhere on each of the sides, and we've got nice big radiuses to the mould, and now that helps twofold. That helps the carbon kind of drape over gently on a nice radius without trying to lift the carbon inside the mould where you're going to get air pockets and voids, and it also protects the vacuum bag, because we're actually going to vacuum bag this in a clothes storage bag, yet we're going to keep this super light DIY, super homeborn. We're not going to have any specialist vacuum bagging materials. We're going to use Amazon closed storage bags and a vacuum cleaner, and radiusing all the edges will stop the part maybe rupturing the vacuum and then losing your vacuum. So this little bead is also there to help me see where to cut the part afterwards, because obviously after the part comes out the mould, I'm going to need to cut it with a Dremel, a little sanding wheel, and then this tiny little bead, which you can barely see on the 3D print, but this tiny little bead that runs all the way around the outside of the part is basically going to leave an imprint on the part. It's going to be my cutting guide. It's not big enough to lock the part in the mold, so it's just, I think it's about Diameter of that bead, I think, was about 0.3 millimeters. Just going to leave a little witness mark on the finished part so I can demold it. I've then gone on to apply a PVA release agent to the mold, so that's going to help me demold the part, make sure the epoxy in the carbon fibre isn't going to stick to the mold. So paint that on, leave that for about 45 minutes to go hard, and the blue dye means you can see where you've painted it and if you've got any spots missing. And then easily just get onto the layup. So the layup, you can see here, I'm actually going to use 3 layers of kind of 2x2 twill fabric. This fabric is about 210 grams per square meter, which means it has very good drapeability. It'll easily conform to all the curves in the mold, and it's kind of a good starting point. I've laid 3 plies of that in, all in the same layup orientation. Going to keep it simple. I'm not going to put any patches in, just 3 layers of that. After mixing the resin, which is really critical, you're mixing the right ratio, by the way, let the resin come up through the fabric, and you can help that by stippling with the brush, pushing down the fabric into all the corners and making sure every bit of that fabric is wetted out, so you've got good resin distribution everywhere. And then on with the next layer, do the same, on with the next layer, do the same. Then, to get a nice surface finish on the interior of the part, we lay something down called a peel ply, which is basically like a polyester cheapo shirt fabric. That helps lift excess resin out the part, but it's also permeable to air, so it helps the vacuum get to everything. And on top of that, we put what's called a breather layer. Now that does a couple of things. Again, it gives the air path, it soaks up excess resin also, and it also protects the vacuum bag for any sharp edges of the mold or the cured carbon. So it kind of does 3 things, and it's really good. These 2 things are pretty cheap, so don't worry about them being consumables. If you have a more complicated mold shape, you may need to snip kind of slots and pleats into the peel ply and breather layer to help it conform to the mold. And then we hit it with a Dyson. Like, this goes into a closed storage bag. Now, you must test the closed storage bags before you use them. Make sure there's no leaks. Put something in it for a couple of hours that's got a nice 3D shape, I don't know, a coffee cup or something like that. Pull the vacuum with the vacuum cleaner and just see if it holds. Now, most home vacuum cleaners will pull about 20% vacuum. If you've got a cordless one like this, you'll need to turn it onto turbo mode or max mode to get that same level of vacuum, but it's pretty good, it's pretty adequate. And that's what you actually want, even if you're using a vacuum pump. About 20% of vacuum, if you're doing something like this, is perfect. So there's no reason why you can't use a home vacuum cleaner, but because you haven't got that consistent suction there and a regulator, you need to make sure that the vacuum bag does not leak, because the curing time is going to be around 8 to 10 hours. You need to make sure that can hold that vacuum all that time. Anyway, into the vacuum bag. When you're pulling down the vacuum, you need to make sure that the vacuum bag goes all into the nooks and crannies and it's not bridging the part. You need to make sure that there's enough plastic in the interior of the mold, so you've pleated it up enough and scrunched up enough that when the vacuum pulls down, it can fill all those corners and all the vacuum can get to everywhere.
If I was a manufacturing engineer, I would kill myself. If I was a manufacturing...
Anyway, then you leave it in hope. And all that time it's curing, you're hoping, well, I wonder if all of that work was necessary. Have I mixed the right ratio of resin? Have I used the wrong hardener? Blah, blah, blah. Yeah, I've done that before. It's a long and annoying mistake. Anyway, after it comes out the mold, then you see your fruits of your labour. Obviously, you're going to need to do a lot of trimming, a lot of sanding. But I have to say, on this Ass Saver one, it was much, much better than the big one, because I didn't really treat the big one too much, because I was, it was more of a first try. And this is Mark 1, okay? So this is my very first trial. I'm dead chuffed with how this came out. Now, you can end up with tiny little air pockets of resin in the corners. There's 1 or 2 on here which you can actually fill with the coating resin afterwards using a little dam and some tape to fold it over. That's not much of an issue. And then to get this nice satin finish, I've just hit it with an 800 grit wet and dry paper. You could actually put another clear coat on top to fill these kind of little voids and little pinholes, and then hit it again with an 800 grit, or you can go really fine on the wet and dry paper and come to a nice glossy polish. I don't really like that glossy polish. I think it makes the carbon parts look a bit dated, so I prefer to keep this kind of satin thing, which I achieved just by 800 grit wet and dry paper. Now, going on to the bigger mudguard mould. Now, this wasn't really made as a mould in the first place. So as a mould, it doesn't have the features like the cutting lines. It doesn't have great draft angles. It's a bit small, like the flanges. Really, with a mould, you need to design nice wide flanges so the carbon can overlap nicely. Whereas on this one, it has a very thin wall all the way around it. So when you pull a vacuum, the carbon actually folds back on itself and basically locks everything into the mould, which was quite a pain to demold. This, I actually experimented with the layup a little bit because I wanted to make it super light and super stiff. So at the kind of root end of the mudguard, it's about 4 plies thick. And where these little leaves come out to go over the seat stays, there's extra reinforcement. And right at the tail end of the mudguard, it's only 2 plies thick. So I did actually lay a few extra bits of reinforcement inside after demolding it to make it a little bit more robust, but it still only weighs 86 grams with a very, very basic layup. And The surface finish of this isn't so good because I didn't spend so long prepping the mold, because I didn't even know if this technique would work, but I'm going to lay another one up, get a better finish. And as you can see here, this carbon flange is perfectly scalloped to the angle of my seat stay, so it fits my bike absolutely perfect. And this is the beauty of making something like this. You can customize it so it fits your bike perfectly. It's not going to fit other bikes, but just goes to show what you can make at home. And the only tool I needed to do all this was a 3D printer. Anyway, I've crammed so much information into this. I hope it's not too long-winded. Do give it a try. Do let me know any comments and suggestions you got down below. Any questions would be really good as well, because I've had parts not curing, I've had carbon in my hair, I've had carbon splinters, I've had carbon all over the garage. The next project will be in creating some more substantial tooling, not from the 3D printer. And then I'm going to be using pre-preg to get a much better quality finish, much better detailed layup, and a lot less mess. No sticky resin on the kitchen table and no carbon hairs in my socks. Don't forget to like and subscribe. Let me know if you've got any comments down below, and cheers, and I'll see you in the next one.